So we're thinking about ratio tables here. So when you have a ratio, we know it's a comparison of two numbers. And when you put it into a table, it's a way of organizing and finding equivalence. So on this, if we call this number one here, we are given the ratio, right? Everything in this table, every comparison is going to match 15/18, right? It'll be equivalent to 15/18, just with a different look. So you'll notice that the top number is sort of like it's sort of like in the form of a fraction, right? It's like the numerator, and the bottom is like the denominator. So we are going to be looking and saying, essentially, what diva can I use to make an equivalent, right? Diva, our fashionista, whatever you do to one piece of this ratio, you have to do it to the other as well. Since they're organized in top and bottom, we can say whatever we do to the bottom, we have to do that same thing to the top. And it'll help us create equivalent fractions or equivalent ratios. 18 here divided by 3 gets us 6. And so we know that if we divide 15 by 3 as well, I don't know why the division thing keeps going away, but we know we're going to get 5. Okay. So you can make smaller ratio comparisons. You can also make bigger, right? You could say 18. Well, I see I could multiply 18 by 2 to get 36. So if I do the same thing to the 15 on the top of this ratio, I know that 36 is also going to be an equivalent ratio that fits inside of this ratio table. What you'll notice down here on this next one here is not all ratios have to have whole numbers, right? You can have decimals inside of ratio statements. So we are given a ratio. We know everything in this table is going to be equivalent to 12/30ths. And there's some ways here that you can some specific ratios we're looking for. You can use this data here to help you, right? So you could say 30. Well, I know if I divide that by 10, okay, divide by 10, that's a crazy way to write a division symbol. You're going to get 3. So if you do that same thing to the top and you divide by 10, 12 divided by 10, well, I'm going to whoop it over. I'm going to whoop that decimal in one place value spot. So I end up with 1.2. And so I don't always have to end up with whole numbers. Something else that you can see down here, if we look here at number 3, is sometimes you'll have 1 right inside of your ratio. When 1 is inside one, it's one of the numbers in your ratio. It's called a unit rate, which you'll explore more. You can use this in the same style, right, that you were using up here. You might kind of go out of order, right? You don't always have to find the ratios in a perfect order. So in this case, I might say, well, I noticed that 1 times 11 is 11. So I'm going to multiply both parts of this ratio here by 11. So 0.5 times 11 gets me 5.5. Okay. So you can go out of order as well. Something else I might think about here, like on number 4, we're given 16/18. So I know that 28 times 2 gets me 56. So if I do that same thing, I can find a numerator over here. What I might also think about is I might just want to simplify this down. I know they're both even, so maybe I chop this one in half, and 28 chopped in half is 14. That can even chop down even more. I could cut the 4 in half again, and I could cut the 14 in half, and I end up with 4/7. Now that this is in a more simplified form, it just becomes easier to see that, oh, there's a relationship. I see a relationship between 7 and 21, or even 14 and 21. But you can then use this, right? You can say 4/7, well, 7, 14, 21. I can multiply it by 3. Then I can also do the same to the 4, 4, 8, 12, multiply it by 3. So 12/21 is going to be an equivalent ratio or an equivalent fraction to think about here. So the data in the table might not always be as easy to see. You might have to manipulate the numbers a little bit, or even find some extra examples to help you really get down to finding the specific ratios you're being asked to find.